Good morning, class. Today we are going to study about the methods of preparation of RX. Guys, with the simplest method, I would try to teach you all these chemical reactions so that organic chemistry becomes easy to you all. Okay, from the first step, we are going to prepare RX. The first procedure by which we can prepare RX is use of ROH. There, ROH stands for alcohol. Okay, guys, let's see the chemical reaction. The first chemical reaction, I'm using ROH. I'm mixing this ROH with Lucas reagent. What is the Lucas reagent actually stands for? Lucas reagent is a combination of HX along with ZnCl2. When I mix this Lucas reagent along with ROH, it's very remarkable to be mentioned that ZnCl2 is acting as catalyst over here and HX is the attacking reagent. As if the HX is an electrolyte, on attack it cleave itself into positive and negative as H is electropositive species, so it do carry positive ion, and X being electronegative, so it do carry negative ion. Now we are going to cleave the ROH, as we know that when the chemical reaction takes place, firstly the breakage of the bond in between the reaction molecule do occur. So the oxygen being more electronegative attracts the electrons of this R towards itself, becomes negatively charged, becomes OH minus, as R donates its electrons, so becomes positive and become R plus. Now this R plus combines with negative portion of HX and become RX. This H plus combined with OH and becomes H2O. That means from this Lucas reagent I was able to prepare my RX. Now moving towards the second reaction, when I treat this ROH with NaBr and H2SO4, again the breakage of the bond in between the reactant molecules do occur. When ROH undergoes cleavage, OH being electronegative acquires negative charge, becomes OH minus, and after donating electron, R become positive. So R plus is being received by me. Now, when NaBr, the salt, undergoes cleavage, it's been seen that Br being electronegative becomes minus and Na after donating electron become plus. Now, H2SO4, as H2SO4 is an acid, so do have tendency to donate H plus ion. When H plus ion is being released from H2SO4, I am going to get HSO4 minus. Now, this R plus attract the Br minus from NaBr and becomes RBr over here. Now this OH minus do have tendency to attract this H plus ion. OH minus and H plus combine together and results in formation of H2O. Now the Na plus attract this HSO4 minus and the product received by me is NaHSO4. Okay guys, now we are moving towards the third reaction in which I am going to treat my NROH with PX3, that means phosphorus trihalide. Okay, in the form of halogen I can prefer the Br and I molecules over here, atoms over here. Now when I am treating PX3, as I know that before the chemical reaction I have to cleave my bond over here, so the PX3 when undergoes cleavage, being more electropositive as compared to the halogen atom acquires a positive charge, and X being negative electronegative component attracts the negative electron towards itself and acquire the negative charge. Now the ROH undergoes the cleavage. ROH, the OH portion is electronegative over here, so attracts the electron, becomes minus, and R becomes plus. As we can see that the three of the X molecules are involved over here, so when I know that R plus do have tendency to attract X minus towards itself, but as the valency of R is plus 1, so it can attract only one only one X ion. So we are taking, to balance this 3X, we are taking 3 moles of ROH. So now 3R plus combines with 3X minus results in formation of 3RX, and the rest of the component will combine together. Before writing the molecule, we should remember that always the electropositive molecule or electropositive component will come at the starting and the most electronegative component will comes at the end of this particular compound. As I can see that I do have O, H and P along with me. The most electropositive component over here is H, which is 3 in number, so I'm writing H3. After this, I can see that in O and P, the electropositive one is P, so I'm writing a P over here, and the last component is O, so I'm writing an O over here, which is 3 number, so it is O3. The component formed is H3PO3. Okay, guys. After reaction with PX3, now I am moving towards the next reaction in which I am treating the ROH with X2 molecule. It's very remarkable that the X2 over here should be treated along with red phosphorus only, then only this reaction do takes place. Now, in this particular reaction, do remember that when X2 is being treated with red phosphorus along with ROH, this X positive X negative ion, this X2 undergoes cleavage, and I am going to get X minus and X plus. Similarly, ROH undergoes cleavage, and I am going to get OH minus and R plus. So the electropositive end, that is R plus, do have tendency to attract the negative ion from this X2, and I'm going to receive this Rx. It's remarkable that X2 when treated with R red phosphorus 2 alcohol, it always replaces the OH component by X minus. Now we are moving towards the next reaction in which I am going to treat the ROH with PCl5. Okay guys, we know that PCl5, that is trigonal planar arrangement, trigonal bipyramidal arrangement. I have placed my PCl5 molecules in trigonal bipyramidal manner, where I can see that the phosphorus is the central atom, acquires the positive charge, and the surrounding atoms are negatively charged. So the Cl are being replaced by the negative charges. Okay, now we are going to cleave this ROH molecule. Till now in these chemical reaction, I had always cleaved that R is an electropositive end, so it becomes R plus, and OH being negative, so it acquired the negative charge over here. But remarkable that when ROH is being treated with PCl5, the certain changes there in the cleavage do occur. As R and O is sharing a bond over here, when this bond breaks, R acquires the positive charge and O acquires the negative charge. Again, this O and H bond undergoes cleavage. H being electropositive component acquire positive charge, and O acquire the negative, so I am placing a 2 minus over here. Guys, now what happens? This R is acquiring positive charge, so it do have tendency to attract the Cl minus ion, so it become RCl, and this H plus as carry positive ion do have tendency to attract the Cl minus ion, so it becomes the HCl component over here. Rest of the components left behind get combined together and results in formation of a compound. What is left behind? I do have P, I do have Cl, and I do have O. I always says that when you are forming a molecule, always write an electropositive end towards the first one. So what is the electropositive over here? It is P. So I place a P over here. Then what is left behind? It's O. I am placing an O over here. Then I do have 3Cl, so POCl3 is being formed. Similarly, one more chemical reaction is being there which is left behind in this particular portion. That is, in this particular reaction, I am going to treat my ROH with what? SOCl2. I am writing my SOCl2, that is thionyl chloride, in this particular manner. That is, it is the exact structure of SOCl2. Okay, now again, in case when ROH is being treated with this thionyl chloride, the cleavage do occur in this manner, that R donates its electron to O, become R plus and O minus. Again, the OH bond undergoes cleavage. H donates its electron, H become electropositive, so acquire the positive charge. O donates its electron, acquires a negative charge and becomes O2 minus. Now in this thionyl chloride structure, I can see that the central atom is sulfur, so it acquires a positive charge. Surrounding atoms acquires the negative charge. Now R is acquiring the positive charge, so it do have tendency to attract the negative component from this particular SOCl2. So I'm going to get RCl from this product, these components. Now my H plus do have tendency to attract the negative ion, as it do acquire the positive charge. H plus plus Cl minus, I am going to get what? HCl. And next what I have to do is I have to write the leftover component. Always remember that before writing the component, I have to write the electropositive component in the front portion, and the electronegative one will come at the back. Okay, what are the left behind components? It is S, O and O. So the electropositive component is S. I'm writing an S over here. What is left behind? O. How many O? 1 and 2. So I'm going to write SO2. That is sulfur dioxide gas has been released. Okay guys, with this I came to end of the reaction of alcohol through which I can prepare RX. In the next session I will continue with the reaction formation of RX with from hydrocarbon. Till then, bye bye.